Hello everyone, I'm at Arizona State University and I'm with Don Balanzat and he is part of the Physics Instructional Resource Team, and we're talking about solar energy and how we can use light to get electricity. So you've got a really cool setup here.
Yeah, lots of light bulbs, lots of solar cells and metallic things around here.
Yeah.
Well, the first step to harnessing the power of the sun comes from what's called the photoelectric effect. And this was something that Albert Einstein discovered actually more than 100 years ago. And basically, a certain energy of light is able to liberate electrons from atoms. And so what I've got over here is a zinc plate that is charged. This is called an electroscope, and it's charged, and you can tell how much it is charged by how angled that needle is right there, right? So the photoelectric effect says that light of a certain energy will be able to liberate the charge from this plate. So what I've got here is just a regular flashlight, and I'm going to use it on this plate, and we can see nothing happens to the charge.
Okay, so this is charged.
Yeah.
And that indicates that it's charged. And when you shine that light on it, nothing's happening. So the electrons are staying put.
Yes.
They're not being liberated.
Exactly, and that's because visible light doesn't have enough energy to liberate electrons off of zinc.
Off of zinc. Okay,
Now-
so the material matters.
Yes, the material 100% matters.
Okay.
So instead, we're going to use this UV bulb, and for
Okay.
that, we need some protective gear.
All right.
This is just coated with some stuff to protect our eyes.
Okay.
And I'm going to turn on this UV bulb and watch closely to the needle.
Oh, the needle's moving.
Yeah, the needle actually slowly is telling us that this zinc plate is losing its electrons. So you can
Okay.
see, yeah.
So as
Yes.
this UV hits this zinc plate, it's causing the charge of the electrons that are in here to go away.
Exactly.
Like
out
leave
into
the plate.
space, yeah.
Oh,
And that's because the atomic structure of zinc, and actually all metals, they have loose bonds for the electrons in the outer shells of their structure. And that's why we're able to do this.
and so if we look, so ultraviolet is right here, and here's visible.
Right.
So visible not strong enough to take
Exactly.
those electrons out of that metal, but ultraviolet is.
Right.
Okay.
And actually anything past ultraviolet, and that's a little dangerous for us, like we don't want to be putting x-rays on this thing, would do the same exact thing at a faster rate.
Okay.
So, yeah.
And so then how can we use this knowledge that Einstein came up with over 100 years ago in order for us to create solar panels and electricity?
Right, so as we play around with materials and we find out what kind of energies work to liberate electrons off of what kind of materials, right? And that's a big question in and of itself. We can kind of play around with what works with visible light, because that's primarily what the sun likes to give our planet. And so we find that silicon, and luckily just so happens that silicon is one of the most abundant elements on our Earth. Silicon has a work function, we call it the work function, that is in the visible light range.
That's great.
Yeah.
And so that's why we create these silicon wafer, I guess,
Right,
for
right.
the solar panels.
Exactly. And so we've got a bunch of solar panels right here. The silicon wafer, as you say, is actually two parts. There's an N-type and a P-type.
Okay.
We put chemicals into each part of the wafers to make one have less electrons than it should have, and some have more electrons than they should have. And in doing so, when we liberate the electrons from the silicon, we can control the path that it goes on.
Okay, so
Yeah.
you can direct it where you want it to go instead of
Exactly.
it just going out to anywhere.
Yeah, exactly.
Okay.
And when we control it that way, we call that a current. Moving electrons is a current, and that is what electricity is. So actually right here, we've got this 3 solar panel setup here. And I've got them connected to this voltmeter, so I'm going to turn this on. And you can see, even with the ambient light in the room from just the fluorescent bulbs in here, these guys are getting 2.1 volts, give or take,
Okay.
right now. And you can see this jumps when I turn on this light bulb, which we will say is our sun,
Ah,
goes
okay.
up to 6.
And so basically, the light from here is hitting our solar panels, and it's causing the electrons in the material to
Yeah.
be liberated, and then we've designed it from an engineering standpoint to flow down the current, the circuit.
Right.
Yes, and then that's flowing into here,
Into
so
here,
that we
and
can
it's
measure
just
it.
feeding out a number so we can see exactly how much voltage we're getting. So yeah, and you can see this is one of the fallbacks per se of solar energy. Imagine a cloud. This will be my hand. You can look at the number here. As I cover it up, it goes down to almost half what it was, and then as I remove my hand, it goes back up to that full value. And so that can be kind of indicative of kind of the way that we have, or the things that we have to keep in mind when we design and place these solar panels.
Absolutely, because you want the maximum amount of light, and like you said, it can pick up the ambient light, and even on a cloudy day, some of that light saturates
Right,
through,
right.
but you're not being as efficient as a very
Right.
clear day.
Yeah.
Yeah.
And so, yeah, that's kind of some of the stuff we have to take into account. But I think it's really exciting to talk about what we can do with this electricity that we're kind of getting for free from the sun. Right? So I've got another setup right here. It's two in parallel, and I have a light bulb that I can turn on. And you can see, oh, it did want to move a little bit. Now, there's not enough energy going to these solar panels. from
Okay,
this light bulb
so
right now.
you've got solar panels, and they're hooked up to this fan here.
Yes.
And you've got light that's hitting the solar panels, but the fan isn't turning yet. Oh, there it goes.
Well, actually, it just needed a jump start. So
It needed
there's
a
actually
jump
some
start.
friction in the motor that this wasn't able to overcome.
Okay.
But once you get past that initial friction,
It will
it's
turn,
a little easier.
It,
to
it gets
turn,
it
yeah.
easier to turn.
And that comes from just classical physics.
So if you turn it off and it
Turn it off,
stops,
you're right. It'll stop.
and
See, there it is again. So now, if I bring it closer, there should be a point where it can overcome the friction.
oh yeah,
There you go.
and it's
Right?
it starts up.
Right. And again, with the cloud cover, imagine we have our machines running off this, be it a cog, a wheel, a pulley, or something like that. If the cloud comes by, all of a sudden it slows down, it stops. That's not good.
Right.
Right. So that's something we also need to consider when we design the solar panels.
So when that electricity is available, how we use it, but also is it potential to store that electricity somehow for later?
Exactly. That's actually a frontier problem for us right now as a society and as scientists. And so, yeah, another way we can use this is a mechanical way to use it. We can also use it just to stimulate other electrical stuff, like this light bulb right here.
Okay, so you have a light bulb here, and it's hooked up
Let's
to
hook up to this array of
these.
solar panels
Okay.
right here. And I've got a floodlight here I'm going to turn on. And actually, it's even powering this fan right here.
Oh, there's enough light there. Oh,
Yeah.
okay. I can see the light bulb on here turn on.
Right, so it's a little bit, it's very weak because it's kind of far away, but as I move the light bulb closer to the solar panels, you can see it does
Oh
get
yeah, it gets
pretty
brighter.
bright. Yeah.
Yeah. So distance matters.
Distance does matter, and that's because the amount of light that's coming from the light bulbs, instead of being spread out in all directions,
Mm-hmm.
more of it is being concentrated on a certain place the closer you are to the light source. So, yeah. These are just a couple of ways we can use the electricity from solar panels.
Well, this is really great. Thank you for sharing this about how different properties really play a role in how we can get that electrons moving from metals.
Right.
And that's based on, again, when we go back to here, the amount of energy
That the light is carrying,
Okay.
as well as the type of material that is receiving the light.
And those two things, as engineers, we've been able to figure out from the science
Mm-hmm.
and the engineering how to harness this and use it to our advantage.
Exactly.
This is great. Thank you.
Yeah, no problem.
Wow, that was
I think
really
that was
good.
good.
That was